Hi, today we are going to be talking about solving percent problems, specifically solving percent problems while using a number line. So there are so many different types of percent problems. We might be doing a markup problem, a tax or tip. We might be doing a discount problem, or you might just be finding the part or the whole or the percent that a certain part makes up. So to do any of these problems, we can draw a number line. The first problem we are going to look at is a problem that says there are 220 boys out of 220 boys in the 8th grade. This is 40% of the total 8th grade students. How many 8th graders are there? So my suggestion is that whenever we're looking at a percent problem, the first thing we look at is what is our part, what is our whole, and what is our percent. So for this problem, the 220 boys would be the part. That is a part that are boys. The 40% represents our percent, and we want to know what is the total. What is the total? So when we are filling in our part, whole, and percent, we would write, let's turn it on to a pen instead of the highlighter, 220 boys and 40%. And we are looking for what is our whole. And let's go ahead and put that on a number line. So when we look at our number line, I always have 0% and 100% when we're looking for part and whole. Then, for this problem, we know that we have 40%. My percents are always on the bottom of the number line. Then 220, the part always goes with the percent. So we're going to put our 220 here, and we are looking for the whole. And the whole thing is always 100%. Now, we can look at this and we can ask ourselves, how could we simplify these fractions? Because we're going to need to get to 100%. So we have this ratio, 220 over 40, and we have the ratio x over 100. And you can choose many different methods to get from these ratios, this proportion, to finding the value of x. And on page 55 or 69 of your toolkit, depending on your version, there are different methods to solve the proportion. For this one, we will look at simplifying that first ratio. So I first notice that I can divide by 2. So I divided by 2, 40% divided by 2, and 220 divided by 2. And that got me to 110 is 20%. Now the great thing is I recognize immediately that I can get from 20% to 100% just by multiplying by 5. So I'm going to multiply this by 5 as well. And when I multiply 110 by 5, I see that x equals 550. And that is the total number of 8th grade students. So if I were to put this on a basic number line, we always have 0% to 100%. Somewhere in the middle, we have another percent, and that represents our part, and 100% represents our whole. So that's the first type of percent problem. Now, the other type that we look at are percent increases and percent decreases. The big difference here is that when we set up our number line, we're looking at change. So we're going to put two number lines side by side. The first one is going to be a decrease. So this one is going to show a decrease. So maybe something's on sale, something like that. So we put 0% at the beginning, and on this one we still have 100% at the end, and that is the original cost. The original cost is always 100%. Then it will decrease by a certain amount, right? So our change goes there, and that would be the amount of change. Amount of change. Then at the bottom, this amount represents our percent change. If we have an increase, so I'm going to draw a little line there. If we have an increase, so again, this might be a markup, this might be a tax or tip. The difference is where our 100% goes. So if we have an increase, the original isn't at the end, it's in the middle, because it's going to be increased by the amount of change. So our 100% goes here, and then it increases the percent change. So this amount still represents our percent change, and the top was our amount of change. So for example, if the percent increase was 10%, we would put that on the bottom, whereas on the top we would put the amount, maybe $3. Let's see if we can fit one quick example down here at the bottom. So looking at an example, let's say we have the bill was $28. We want to leave let's do a 15% tip. How much do we pay? And we're going to find how much do we pay all together. So again, we're going to draw our number line here. And I'm going to extend it a little bit for the 15% tip. So we have our 0%, we have our 100%, and then this time it's going to increase. So when I put my numbers on here, the 28 is the original amount. The amount of the increase is 15%. So when I set up my ratios, I want to find this number up here, this X. How much tip do we leave? Then we'll be able to find the total we paid. So my ratios, I have 28 over 100 equals X over 15, right? Now, our tip isn't always going to be a whole amount, right? It's not always going to be a whole number. A lot of times when we leave a tip, we leave dollars and cents. So to calculate this, we need to find what is 15% of that $28, right? So you have options on how you could do this. We could use cross multiplication, do 15 times 28, and then divide by 100. Or we could divide 28 and 100 each by 20 to find 5%. Whichever method you use to find x, I'll just quickly remind you that we can cross multiply these ones, right? To find 100x is 28 times 15. When we multiply 28 by 15, we get 420. I'm running out of room down here at the bottom. We have 100x equals 420. So we divide both of those by 100 and we find that our tip is going to be $4.20. So x equals $4.20. To find how much we pay altogether, we are going to add 28 plus $4.20, and we find our total that we should pay is $32.20. Sorry, this is right down here at the bottom. This is so important to learn. You will use this often in life, making sure you're leaving enough tip or that you're being charged the correct tax, and all of those important percent problems in real life.